Okay, so now we are going to look at how to calculate the value at risk for a multi-asset portfolio. The value at risk that I've calculated here represents the maximum level of loss that we expect for a given level of confidence. The most important aspects of the value at risk calculation are the portfolio return mean, which I've calculated here, and the standard deviation on the returns. Before we get to the value at risk calculations, we need to estimate the variance covariance matrix for the portfolio. So I have my asset portfolio here. I have the 5 assets which I selected at random, and I have my daily prices here. Now, because we are estimating one day VaR, we do not go too far back in time, as the information may be relevant for our daily VaR estimation. Typically, 1 month of market data should be enough. So I have about 17 observations here, and I have all the asset prices here. Now we proceed by getting the returns over each day. So we get the natural logarithm of today's return over today's price, over yesterday's price. We get the average of the returns for each asset, and you may wish to get the standard deviation and variance as well. Now I have the variance in color here because I will use these values to compare against the variance covariance matrix to see if I done everything correctly. After getting the average returns for each asset, we proceed to get the excess returns on each asset. Now this is taking the observed returns for the day and subtract the average returns on that asset. It gives you the excess returns, and excess returns will be used in the estimation of the variance covariance matrix. Now, the variance and covariance matrix is critical in estimating the standard deviation. To get the matrix, we take the excess returns and transpose for excess returns, and then divide it by the number of observations. We do this by entering the function of equals m mult. We m mult multiply and then transpose the excess returns here for given excess returns, and then we divide by the number of observations, which we have 17. Now we press the Control, Shift, and Enter to get the value for variance for Amazon stock. Now, to get the full matrix, we highlight the cells and pull them across for every asset. We go back to our function up here. We hit Control, Shift, and Enter again, and now we get our variance covariance matrix. Now, the horizontal values here represent the covariance between each of the assets, and the diagonal axis here are the variances for each of the assets. Now, because these are highlighted again, so I can check if I've done this correctly by comparing this value here to the one up here that I've calculated before, and I can see that the variances are the same. I can confirm now that the variance covariance matrix should be correct for our 5-asset portfolio. Now I'm going to proceed to use this variance covariance matrix in the value at risk calculation. So here I have copied over the variance covariance matrix that we estimated earlier. I've also copied over the mean returns, and I have estimated my portfolio proportions. Now, you may wish to obtain an optimal portfolio, but for the example purposes, I'm just going to assume that the proportions for each asset are the same. Now, to get the one-day value at risk, we need an initial investment in our portfolio, which is going to be this 1 million here. To get the returns on the portfolio, we simply get the matrix product of the transpose of the mean returns and the portfolio proportions. We need to hit Control Shift and Enter to get the accurate value here, and for the standard deviation on the portfolio, we get the matrix product of transposing the portfolio proportions by the variance covariance matrix and the portfolio proportions again. We get the square root of this value here. We hit Control Shift and Enter again, and we get the standard deviation for our sigma, which is again half a percent. Now we can get the mean investment and the standard deviation on investment by simply multiplying the mean returns by the investment and the standard deviation by the investment up there. This will help us to get the cumulative probability density function, which is over here. But first, we can actually estimate the one-day value at risk right now. We can simply find a cutoff point on our investment, which is the norm's inverse of the significance level, which is our 1%, which is this 0.01. We get the norm's inverse of the mean returns, as well as the portfolio, as well as the standard deviations on the portfolio. And the cutoff point here is this 988,000. If we subtract this away from the initial investment, we get the one-day VaR. So just to get the cumulative probability density function, we can simply enter the function of norm's distribution for the mean investment, the standard deviation on investment, and the cutoff point, and we enter true for normal distribution, and we get the cumulative distribution function. Now we already have estimated the one-day VaR at the 1% significance level, but if we wish to estimate for more than 1 day, we can simply take the one-day VaR and multiply it by the square root of the number of days that you wish to estimate, which in our case is 10. So this gives us the 10-day value at risk at 35,839. Now this example showed how you can obtain the multi-asset portfolio value at risk through variance and covariance matrix.